Good morning, everyone. I'm Vishwas, and I will help you learn about matter in our surroundings. That is chapter 1 of class 9. So, in this chapter, we are going to learn about few things. That is, first of all, we are going to learn about the introduction part. Then, what are the physical nature of matter? Diffusion. What is meant by diffusion? Characteristic particles of matter. There are few other characteristics states of matter, that is solid, liquid and gas, and there are two more states that we are going to explain in last of this chapter. Change of state of matter, effect of temperature, latent heat of fusion and latent heat of vaporization. Then how this effect of change of pressure helps in this chapter. Then what is evaporation and what are the factors affecting the rate of evaporation. Evaporation causes cooling. How and where all these applications takes place. Then these are the two states of matter that I was telling you about, that is plasma and Bose-Einstein condensate. So let's start the chapter. So in the introduction we are going to learn about Panch Tattva. You all might be knowing or heard about Panch Tattva. What is Panch Tattva? Air, earth, fire, sky, water. These are five Panchtattvas that we have in our Indian books as well as in our science books. Plus, all over the world, we are knowing all these as the Panchtattva. According to them, living as well as non-living things are made up of elements. So every living being is made up of different kind of elements that we are going to see, but there is one common thing in between all, that is named as atom. Atom. I'm repeating again the name as atom. So in this chapter we are going to learn about the physical properties and the chemical properties of different states of matter. So first of all we should know about the physical nature of matter. What do you mean by the physical nature? So, in this, matter is made up of particles. You all might be knowing about this thing, that everything is made up of particles, or we can say in scientific language that everything is made up of small particles called atoms, right? Whether it's solid, whether it's liquid, or whether it's gaseous. All matter constitute of very small particles. These small particles are called atoms. See this? All these small particles from where the each and every state of matter has been made, or whatever the object you are seeing around yourself is made up of small particles known as atoms. For example, these particles of matter, you can't see it with your normal eyes or naked eyes. It can be seen only with the help of microscope. Particles of matter are extremely small, that's why you have to use microscope for that. Cannot be seen through your normal eyes. So particles of matter are continuously moving as they possess some kinetic energy. Have you heard about this word kinetic energy? Yes, you have heard in class 8 that every particle is having some energy, and if that particle is moving or is in motion, it is having some kinetic energy. So, with the increase of temperature, the kinetic energy of the particles also increases. Have you ever done at home also? Yes, we can relate it with a simple process of boiling water. Have you seen the boiling water? When you boil the water, what happens? In that case, the heat is transferred to the water with the help of gas stove, and that water molecules start coming up. Why they started coming up? Because earlier they are stable, or we can say they are having less kinetic energy. But as soon as possible, you have provided some kinetic energy to that particle, so those particles started coming up due to increase in temperature, and due to increase in temperature there is also increase in the kinetic energy of the particles, so it start moving faster. So this is the concept, or very small concept, about the kinetic energy, right? So I hope you have understood this. Diffusion. What is diffusion? As you can able to see in this figure also, that there is a zigzag movement of the particles. What do you mean by zigzag movement? See this particle is here, then it is going there, here, then here, then here, then here. This is not a continuous movement. This is that the particles can move in any of the directions. So this kind of movement is known as zigzag movement, and this process of zigzag movement of the particles of matter is known as Brownian motion. This is the most important point that I am explaining here. The zigzag or random path traveled by the particles of matter is known as Brownian motion. It can happen mostly in gases, it can happen in liquids also, but least in solids. Why? Because solids particles are quite tightly packed, liquids are little bit tightly packed, but it can flow easily. And in case of gases, these particles are most loosely packed, so they can move from one place to another quite easily. So here I have written something. Intermixing of particles of two different kinds of matter on their own is called diffusion. What does it mean? Intermixing. You know this word intermixing means आपस में mix होना, right? When these particles get intermixed with two different types of matter on their own is called diffusion. Let's take an example. आपने घर में नींबू पानी तो बनाया होगा सभी ने, या चाय बनाई होगी, राइट? सो उन प्रोसेसेस के अंदर हम लोग क्या करते हैं, जब नींबू पानी हम लोग बनाते हैं, वी यूज टू टेक लिक्विड, right? Liquid, that is water, in which we are going to dissolve some sugar first of all. So sugar is what? A solid form, right? When we add some sugar into the this water, then it start dissolving. Or when we raise the temperature a little bit, it continues to dissolve much better. So what we are doing in this case is that we are just mixing two states of matter, that is sugar, that is solid, and we are dissolving sugar in liquid, that is water. So liquid, water, and sugar, solid, we are mixing these two states of matter, right? So rate of diffusion increases on increasing the temperature. While making a nimbu pani, you might have seen or observed, if your mothers used to make at home, that what they used to do is they used to take some amount of water first, and they used to dissolve some sugar, whatever the quantity you want to take, and then they used to heat that water up so that the sugar will dissolve soon and much easier. For a proper dissolving process, you need to heat that water. Why you are heating that water? So that the sugar should be dissolved in proper manner, right? So this is known as basically the intermixing of the two states of matter, which we called as diffusion. Diffusion basically means, if in Hindi I am going to explain you, diffusion means हम दो चीज़ों को अलग अलग चीज़, जैसे एक सॉलिड हो और एक लिक्विड हो, दोनों को मिल करके एक जगह मिला दें, ठीक है? तो उसे हम कहते हैं डिफ्यूजन। जैसे हम लोग क्या करते हैं, हम लोग जब चाय बनाते हैं तो चाय में क्या करते हैं, चाय बनाने से पहले हम थोड़ा सा दूध लेते हैं, दूध के अंदर हम चीनी जब डालते हैं तो उसके साथ साथ टेम्परेचर थोड़ा बढ़ रहा होता है। तो टेम्परेचर जब बढ़ता है तो चीनी अच्छे से डिजॉल्व होती है। अगर हम चाय को बनने के बाद उसमें हम चीनी डिजॉल्व करना चाहेंगे तो चीनी को थोड़ा टाइम लगेगा डिजॉल्व होने में, और हमें उसे कॉन्टिन्यूस स्टर अप करना पड़ेगा, राइट? सो दिस पर्टिकुलर प्रोसेस of intermixing of two different states of matter is called diffusion. I hope you have understood this concept. So coming to the next concept, that is characteristic particles of matter. So before knowing this characteristic particles of matter, you should be knowing about matter. So what is matter first of all? Matter is basically what? Matter is basically a kind of thing that we can see, we can touch, we can feel, or if we will give a complete definition of this, anything which is available in the environment that we can see, touch, feel by any one of our five senses, or which is occupying some space and have mass, is called matter. So the complete definition is anything which occupies space, have mass, and can be felt by any one of our five senses is called matter. I'm repeating again. Anything which occupies mass, have fixed shape or volume, and can be felt by any one of our five senses is called matter. So, we are going to learn about matter and its states. So, first of all, let's learn about the states of matter. First one is solid state. So, what is solid state? The space between the particles is very less. As you can see in this figure, the particles are quite tightly packed and the space between the particles is quite less. So if the space is less, so what happens? We talk about force of attraction. What is meant by force of attraction? Force of attraction means the force of attraction between these two particles. As you can able to see the green and purple particles in this figure, so they are quite tightly packed. Why they are tightly packed? Because of this force of attraction, right? That's why they are called as solids, and we say that the particles of solids are closely packed. I hope you have understand this point. Now coming to the next point, solid maintain their shape even when they are subjected to external force. So when solid changes shape, have you seen what happens when the solid changes its shape? You have to apply some pressure on it, right? For example, have you seen a plastic box which is empty from inside, or take it as a geometry box, right? So if it is kept on the table, does it change its shape? Your answer is no. But when you apply some force or when you hit with an hammer, that is, you are applying an external force on that body or an object, then it can change its shape because you have applied some external force. But that doesn't mean it is not a solid. It is a solid, right? So solid cannot be compressed. Some solids can be compressed like sponge, but most of the solid cannot be compressed. Solid can be compressed only by applying external force, as I have explained you in the previous point. The kinetic energy of the particles is very less. Why kinetic energy is less in solids? Kinetic energy is less in solids. That's why they are closely packed. If the kinetic energy of the particles of solids is high, then what will happen? All these particles keep on moving from one place to another, right? Like in liquids or in gases. So, if yes, you have understood the point. I have just told, like in liquids or in gases. That means if I will apply some amount of energy, or I will provide some amount of energy to this solid, then what will happen? All these particles will gain some energy and it will go from one place to another. That means this bonding has been loosed up, right? When this bonding has been loosed up, then the solid gets converted into liquid or gaseous form. That means it can change its state also, right? Now, coming to the another state of matter, that is liquid state. What happens with the liquid state? Let's see the properties. The space between the particles is slightly more as compared to solids. As you can see this point, the space between the particles are slightly more as compared to solid. Let's see the space. As you can compare these two shapes, this one and this one. This is for solids and this is for liquids. Yes, you can see the difference between both the molecules, that they are quite loosely packed and solids, and they have, that means, weak force of attraction. The force of attraction between the particles is strong enough to hold the particles together, but not so strong to hold the particles in a fixed position. That means the particles can flow. That's why the liquids flows from one place to another, and this property of liquid is known as fluidity. The tendency to flow of a liquid, the property that show the tendency to flow of a liquid is known as fluidity. Right? Have you understood? I am again repeating this. The tendency or the property to flow of a liquid or a gas. It can be happening in case of gas also is known as fluidity, right? So fluidity is the property to flow. The kinetic energy of the particles is more than that of solids. How come? As I have explained you earlier in case of solids also, if I will provide energy to these particles, what will happen? It will go from one place to another, and that means their force of attraction gets weakened up. So, due to which it is going to be converted into liquid state or in gaseous state. So, when we are applying energy to the solid particles, what will happen? It gets melted into liquid form, or it can be directly converted into gaseous form also. Suppose we are applying a very small amount of energy that it has been converted into liquid form only, then what will happen? The space between the particles will be visible. As you can able to see in this diagram, it will be visible only at the microscopic level. You can't able to see it with your naked eyes. Please. Liquids do not have fixed shape. You know this point. Liquids do not have fixed shape. For example, what will happen? If you will take two containers, for example, one glass and one jug, what will happen? If you pour some water from jug into the glass, it will take the shape of that glass. And if you will see the jug, it has the water kept in the jug has taken the shape of that particular container. So, but one more point is there, it has a fixed volume. Yes, it is not having a fixed shape, it can have a fixed volume, because as you can able to see the amount of water that is kept in the jug, if you have poured into the glass, the water amount is same but its shape has been changed, right? Liquids can take up the shape of the container in which it is poured. This thing you can easily able to do it at your home also. Now, coming to the next point of the characteristics of liquids, the kinetic energy of the particles is more than that of the solids, right? I have explained to you this point earlier also, that the kinetic energy is more. That's why these spaces can be visible to you, and that's why this is liquid. When these spaces will be little more, or we can say we are going to provide little more energy to these particles, what will happen? It gets converted into gaseous form, right? So liquids cannot be compressed much. It can be compressible, but you cannot compress it to a higher extent. If you will do that under certain temperature or pressure conditions, then it will get converted into solid state, right? So coming to the next point, gaseous state. So now we are going to learn about another state of matter, the third state of matter, that is known as gaseous state. The particles are much farther apart from one another as compared to solids and liquids. This point I have already told you earlier also, that the particles, as you can able to see in this figure, are quite away from each other. This is because of their kinetic energies, right? And the kind of motion they are doing is known as Brownian motion. As we have explained earlier, the force of attraction between the particles is negligible. So in this, as you can able to see, the force of attraction between the particles is quite small. That's why we have used this word negligible. Negligible doesn't mean they don't have. It is having, but it is quite small. Hence, particles of gases move freely in the directions or in all the directions quite easily. Gases thus makes or diffuse into other gases. That's why we can't able to predict how many gases are there nearby us. There are numerous of gases that has been diffused with each other without any kind of problem, right? Because their particles are having a large amount of space in between them that they can adjust anywhere. The particles of gas have maximum kinetic energy, as you can able to see in this point. The particles of gas have maximum kinetic energy. They move with high speed in all directions and can exert pressure on the walls of the container. See this figure. as you can able to see, this particle is going here, this particle is going here, this is going here, this is going here. What will happen at the end? It will strike the walls of this container and will exert certain amount of pressure on these walls. This process is also known as bombardment. I am repeating this word, bombardment, right? What do you mean by this word? When these particles strike the walls of the container, they exert certain pressure on the walls. This process is known as bombardment, right? So gases neither have definite shape or not definite volume. You all know about this point. Gases do not have any kind of fixed shape or not fixed volume. Why? Because, for example, you might all have used deodorants at your home, right? So when you spray a deodorant on your body, what will happen? The smell of that or the fragrance of that particular perfume gets spreaded in the whole room within a fraction of seconds, because the particles of gases, they just take the shape of the container in which it is kept, as I have explained you earlier. So if they takes the place of the container in which it is kept, what will happen? Yes, you can imagine a room in which you have sprayed a perfume. So what will happen in that whole room? The gaseous molecules have been spreaded, and the smell of the perfume can be observed from any of the corner of the room. Yes. So coming to the next point, nor a definite volume. So as you can able to see, a small perfume, if you have sprayed, it is just few milligrams, right? So milligrams can occupy the whole room. So it do not have even definite shape nor a definite volume. So gases can be compressed easily. You can compress the gas easily. Like LPG cylinders used at your homes, you can able to see it contains a large amount of gas, and a little amount of gas, if leaked up from the LPG container, the gas has been spread in the whole house, and you can able to feel from each and every corner of your house that your cylinder has been leaked up. This is all about the three states of matter. So, this chapter we will continue in the next video. Better to just go through it, and if there is any doubt, you can share your doubt below through your post, or you can even contact me on this number. Right? Thank you, class. Have a nice day.